Everyone. Today the topics I'm going to be covering is the gradient and directional derivatives. So this is from WeBWorK homework 9, question 24. So we are given that with the function f of x of y equals x over y, a point of negative 1, 3, and a vector of 2i plus 4j. So this is a 5-part question. Question A, it asks us to find the gradient of f. The gradient of a function is defined as the partial derivative in respect to x, I, plus the partial derivative in respect to y, j. So with the function above, the partial derivative of x is 1 over y, and the partial derivative of y in respect to y is negative x over y squared. So therefore the gradient is defined as 1 over yi minus x over y squared j. Question B asks us to evaluate the gradient at the point P. So we know that point P is negative 1, 3. So we're just going to substitute in negative 1 for x and 3 for y. So the partial derivative for x at this point is going to be 1/3, and the partial derivative for y at this point is going to be 1 over 3 squared, or just 1 over 9. Therefore, the gradient is going to be 1/3 I plus 1/9 j. So now we're going to get into more directional derivatives. This asks us the directional derivative of the function f at point P in the direction of the vector v. So the directional derivative in the direction v at f at a function f is defined as the gradient of the function times the the vector u, where u is defined as the unit vector of v. So I just substituted in here what we know with the gradient that we got from question B, and then what we need to find here is u. So u can be defined as the 1 over the magnitude of v times v is how we can get the unit vector of v. So the magnitude of v is going to be the square root of the components squared. The components are 2, 4, so 2 squared plus 4 squared in a square root. That's going to come out to the square root of 4 plus 16, or the square root of 20, which we can simplify to 2 rad 5. So now we know that is the magnitude. So to then find the unit vector, we're going to set 1 over that magnitude we just found times 2i plus 4j. That's going to come out to 1 over rad 5i plus 2 over rad 5j. And to rationalize the denominators there, u is going to be rad 5 over 5i plus 2 rad 5 over 5j. So that's how we found the unit vector. Now we need to finish the problem, which I did on page 2 here. So the directional derivative is defined by, as we said before, the gradient we found in part B, and then now we have that unit vector that we just found. So we're going to need to find the dot product between these two vectors. So let's multiply the components of I and add that to the product of the components of j here. So 1/3 times rad 5 over 5 is going to be that rad 5 over 15, and then plus the 1/9 2 rad 5 over 5 is going to be 2 rad 5 over 45. So to get a common denominator here, we're going to just multiply the numerator and denominator by 3 here. So we get 3 rad 5 over 45. So now that makes it easier for us to just add these. That's going to give us 5 rad 5 over 45. Just simplify that out to rad 5 over 9. So the directional derivative in the direction v of the function f at negative 1, 3 is going to be rad 5 over 9. So for D now, we're going to need to find the maximum rate of change of f at the point P. The max, this is going to be defined as the magnitude of the gradient of f at the point negative 1, 3. Now we know from part B again that comes back that the gradient of f is 1/3 I plus, or the gradient of f at the point is 1/3 I plus 1/9 j. So we're just going to square these components and put it under a square root. That's going to come out to be 1/9 plus 1/81 under that square root. So we're going to find a common denominator here again, so it'll be easy to add these two fractions, and that will make it 9/81 plus 1/81, which will then go to 10/81, and square the top, square the bottom. We have rad 10 over 9, so that's going to be the answer to D there. Now the last part is E. I need to find the unit direction vector in which the maximum rate of change occurs at P. So we just found that maximum rate of change. Now we're going to use that with the original gradient vector and put that 1 over that value we got there, which is going to simplify to 9 over rad 10 times 1/3 I plus 1/9 j. That's going to come out to be 9 over 3 rad 10 I plus 9 over 9 rad 10 j. So we have that down here, and we're just going to simplify it to 3 over rad 10 I plus 1 over rad 10 j. Let's rationalize the denominator there. Is going to be 3 rad 10 over 10 I plus rad 10 over 10 j. That's going to be that unit vector that we have there of the maximum rate of change. I hope that this review was beneficial to all of you. Please excuse my messy handwriting. It's already bad as it is, and I've been in a sling the last couple of weeks. So it's been a little difficult to write, but I hope you can read all this, and I hope that this video was helpful for all of you.